Good afternoon, guys. Before we start the lecture today, we still have a couple of announcements. One of them is I want to know how many of you are not on Google Classroom right now. Okay. So this is your last chance to join. The thing is, if Ravid or Mehreen or whoever is doing it starts grading your worksheets and quizzes and cannot find your name in Google Classrooms, later on you will get a 0 on that. Okay? So do it ASAP. Okay? Before they start grading this stuff. दूसरा मैंने कल announce किया था कि you're going to make 2 groups for 2 of the activities that we are going to do later. Okay? उस groups उसके लिए आपकी जो deadline है वो आज midnight है. Okay? You have to do it by midnight today. If you don't, what we are gonna do is we're gonna give you random groups ourselves. Okay? So you can't complain after midnight today if you're assigned to a random group. Okay? And that's gonna be the group that will stick with you throughout the semester. You won't be able to change it. Okay? I think Namreen shared something on Google Classroom where you can go and put the names of your group members there. Okay? So do it preferably right after this class. Okay? What else is there? Is there anything else here? No, we are good. Okay. Any questions? You have something to say? Okay. Let's move on. So this is where we were when we left yesterday. The quantifiers. We saw 2 different ways to transform a predicate statement into a proposition. One of the ways was that you replace the variable with a constant value. Okay? That's what we have been doing over some time now. Well, at least a couple of classes. Okay? We have a statement which has variables and we fix those variables with some constants, and now it becomes a proposition. Okay? It has some truth value. It's either true or false. Another and slightly more interesting way to transform a propositional formula or a predicate formula into a proposition is using what we are learning today, quantifiers. There are 2 different quantifiers. One of them is the universal quantifier, the other one is existential. The universal quantifier makes the statement about every member of the domain that your variable belongs to. Existential quantifier says that some member of your domain that statement applies to. Okay? And by some we mean at least one. That's what some means in discrete sense. Okay? Some means at least one. Okay, let's see. Here are a couple of examples of universal quantifiers. I consider them fun examples. So the first one is when I say for all cats love napping in sunbeams. So here the domain is all cats and the statement is अगर मैं यहाँ पे कुछ x होता cats की जगह ना, तो this would have been a predicate. This is a quantified predicate now. Okay? So यहाँ पे for example for all ना होता, this would have been a predicate. This for all quantifies it universally. It says that for all members of the cats family or cats domain, this statement holds. It might either be true or false, but it's a proposition now. Alright? Keep the distinction in mind. When I say that this is now a proposition, what I mean is that it has a truth value. It might still be a false proposition or true, okay? But it's a proposition now. For all programmers, drink coffee by the gallon. The statement is saying that every programmer drinks coffee a lot. Okay? Again, this might be true or not. And for all professors claim their subject is the most interesting of all the subjects. Is anyone here who does not understand meaning of any of these statements? Or is it perfectly clear what each of these statements entail? Yes, no? Is it clear? Yes. Are we good? Yes. People who say no. No? No? Okay. So let's have a look. So what I'm saying here is that this is a statement. अगर यहाँ पे For all ना होता. Okay, what I'm saying is that X is a member of family or set of cats, and X loves napping in sunbeams. Okay, that thing itself is not a proposition. Okay, because it's possible that the statement is true for some cats, it's possible that statement is not true for some other cat. Until I specify what X means there, that statement is not a proposition. Okay, but when I quantify it, without replacing X with a particular member of the family, I quantify it, that I'm saying the statement for every member of the family, that thing becomes a proposition. Okay, we'll see more examples. Okay, hopefully it becomes clear. Again, on the universal quantifier, P of X is the statement that X must take the discrete structure course, and Q of X is the statement that X is a computer science student. अब यहाँ पे, since these two things are predicates, right? These are predicates. We agree on that, right? There's a variable and there is a relation or property defined on that variable. So it's a predicate. The first one, X is a variable, और इसके नीचे domain define हुई हुई है. Okay, the domain is all students of ITU, and then I'm specifying a property that is associated with that variable, right? And the property is that they have to take the discrete structures course, right? So this thing is itself a predicate. और जिसका दूसरा word हमने ये कहा था, it's a propositional formula. And the second one says that X is a computer science student. It's also a predicate. There is a variable and then there is a property associated with that variable. Okay, so these two things are predicates, where we have variables and some properties, and then for each of these variables I have a domain defined. The domain is the students of ITU. All right, now I'm going to convert these predicates into propositions by using universal quantifier. Okay, here's the statement: all computer science students must take discrete structures course. Okay, this thing now is a universally quantified proposition. Okay, so how do we write this statement in our logic now? How do we mathematically write it down? Go ahead, give it a try. What do I start with? Raise your hands. Yeah? For all.
Q of X.
Okay, for all के फौरन बाद, remember, burn it in your memory. For all के फौरन बाद variable का नाम आएगा. Okay? For all जब भी लिखेंगे या there exists जब भी लिखेंगे उसके फौरन बाद variable का नाम आएगा. Okay? So किस variable को आप universally quantify कर रहे हैं? Okay, the variable that you are going to universally quantify for all X, right? So whatever comes next is implied for all members of X. Okay, for all X, so उसके बाद
Q of X belongs to Q of X.
Q of X, उसके बाद क्या कहा आपने?
Belongs to
Belongs to तो हमने अभी तक define नहीं किया. We don't know what belongs to is. क्या? देखो, there exists वहाँ पे आएगा जहाँ पे some का word आया है या there is at least one, इस तरह का कुछ word आया. यहाँ पे ऐसी कोई statement नहीं है. Okay? यहाँ पे all का word आया है. All means के you need to use universal quantifier, right? Okay, so for all X तक तो ठीक है बात. For all X is correct. Then what? So we need to say that computer science students must take the discrete structure course. Okay, go ahead, say it. Try it again. You're almost there.
For all X, Q of X implies Q.
अब हाँ ठीक है, बिल्कुल आप सही कह रही हैं, लेकिन अभी तक हमने implications को define नहीं किया इस क्लास में. Okay, so we cannot use implication here. जो हमने define किया है वो क्या है? Conditional, right? So for all X, I want you to sorry. Yeah. So for all X, Q of X, then P of X. Okay. For all X, if QX, then PX. Okay, that's the statement for this one. Do we all agree on this? Yes? And that's the only way to express जो logic हमने अभी तक पढ़ी है, that's exactly this thing. उसमें और इसमें कोई फ़र्क नहीं है. Okay, you should be able to figure this out. That for all x, q of x then p of x is exactly what this thing is saying. That all computer science students must take discrete structures course. Okay, this is gonna appear a lot in your quizzes and in your exams. Okay. So burn this in memory, that you have an English statement and then you want to convert it into a logical formula in mathematics. Are we on the same page?
Yes.
Okay, so everyone agrees that this is the answer for all f, q of x then p of x. Okay? Yes?
Yes.
Alright, let's move on. Let's see another example. How about this one? So let me read it for you. The statement now is that everyone must take a discrete mathematics course. Discrete math and discrete structure, let's say, are the same thing. Okay? Or be a computer science student. How do we write that down? Yeah.
For all x,
Yes?
q of x or q of x.
Yeah. Yeah. It's simpler. For all x, q of x or p of x. At least one of them must be true. Okay? Good. You had a question? Okay, good. All right. So that's the formula for it. For all x, q of x or p of x. Do I have one more of these? Existential quantifier. So the definition of existential quantifier is p of x is true for some value of x in the universe of discourse. Okay? We use the notation there exists x p of x. Remember quantifier के फौरन बाद variable आएगा. Okay? And this is how we read it. There exists x. Similarly, if the universe of discourse is finite, say n1, n2, n3, and k, what we are actually saying is that there exists p of x is equal to this statement. Okay? P of n1 or p of n2 or p of n3 until we reach the last member of that set. Okay? That's the definition of there exist. Existential quantifier allows us to find at least one instance where the statement holds true. Here are examples. There exist students who love math. It's saying that let's say कि यहाँ पे students की जो domain है वो ये class है. So I'm saying that there is someone who is passionate about math. Okay? This is not, again, this statement is not negating the possibility that everyone is passionate about math. Okay? That thing is still possible. It's not saying that some people are passionate about math and some people are not. That's not what this thing is saying. All this thing is saying that there is at least one person for which this statement is true. Okay? It's not saying that there cannot be more than one. Right? So keep that in mind. The second one says that there exist available parking spots. Again, it means that there are spots that are waiting to be found. Yeah. Okay, so in general, when are these quantified statements true or false? So all x, p of x is true when p of x is true for every x. And there exists p of x is true when it's true for at least one x. Okay? For all x, p of x is false when what? Don't read the slides. When there is at least one x for which the statement is false. Okay? If there exists one x for which the statement is false, then the universally quantified statement would be false. Okay? And the existentially quantified statement would be false when the statement is false for every member of the discourse. Alright? So they have this kind of dichotomy in them. Are we good? Okay. Then let's write the statements for these. The product of two negative integers is positive. How do we write this down? Think about it, spend 10 seconds or maybe 30. So when I was learning counting, discrete math in combinatorics, I learned it from some guy called Jeff Kahn. He's a professor at Predicates. He used to ask these questions, never use the slides, but he used to ask questions, writing them on the board. And then he would say, okay, you have 30 seconds to answer this question. But his clock was 3 times faster than our clocks, okay? After 10 seconds, he would be, your time is done. Let's move on, okay? So, your time is done. Aapka time mein story mein kha gaya hu. Alright, so how do you write? The product of two negative integers is positive.
For all q of x is positive. Let's say q of x is the multiplication of negative integers.
Don't use English, use the logic, okay? So, try again.
For all.
I'm going to give you 10 seconds. Think about it, and then it's a bit tricky, okay? Yeah, it's not simplest of the. I'm pretty sure whatever you're going to say is wrong, but that could be a stepping stone जिसके ऊपर हम correct statement build करेंगे, okay? You had something, yeah.
For all negative x square greater than 0.
Okay, let me try to write down what you're saying, okay? So you're saying for all x, for all, उसके बाद क्या आएगा?
Negative x square greater
Now यहाँ पे variable आएगा, okay? What's the variable?
x.
Okay, for all x.
Negative x.
यहाँ पे किया ना, उसके बाद फिर आपको यहाँ पे domain define करनी है, okay? X is
0 लिख सकते हैं.
yeah, sure. वो हम लिखते हैं. यहाँ पे पहले मुझे domain बताओ. X की domain क्या है?
Less than 0.
So X की domain is negative numbers.
0 to negative.
Is it talking about integers? So negative integers. That's what you're saying, right?
Yes.
X is negative integers. Another way to write this thing is
Square bracket.
W negative, I guess. I don't know. Z, I guess. Z negative. Okay. All right. For all x, what do you want to say now?
Negative x square.
So x is already a negative integer. हमने ये define किया ना, यहाँ पे x is a negative integer.
Into x.
X into x, okay,
Greater than 0.
is greater than 0. Yeah, I guess you're right. For all x, x into x is greater than 0. So did I say positive? Yeah, I said positive. So this is again wrong, but it's on the where we want to be. Okay, there is something wrong here. I want someone to figure out what's wrong here. Yeah. For all x and y. Okay, good. So the thing is, यहाँ पे you are just squaring things. You're not multiplying things, right? Because x times x is just square. Okay. Over here you're saying that square of every negative number is a positive number.
Y भी लेना.
So I'll have to do for all x and y, where the domain of y is the same as domain of x. Okay. What next? Yeah. That's helpful. X into y is greater than 0. Okay. So that's the statement that I was looking for. Good. Nice. Just want to make sure that there is no. Yeah. That's the answer. Okay. So you see, this is a bit tricky. It's not obvious. Okay. At times to figure out how to write the same. It's an obvious statement, but to write it down without any ambiguity in a logical formula, it takes some practice. Okay. How about the next one? The difference of two negative integers is not necessarily negative. That's an interesting one. Who has an answer? I don't. Let me figure it out myself too. The difference of two negative integers is not necessarily negative. Yeah.
There exists x and y.
Okay. There exist x and y,
for which x minus y is greater than 0.
x minus y is greater than 0. Is क्या? Hold on a second, let me just write it down. उसके बाद हम देखते हैं. और x और y की डोमेन आप कह देंगे ये है ना? The differences to negative integers is not necessarily negative. क्या? Okay. Yes? Cool. So, or okay. So, अच्छा, जब भी आप चीज़ें क्वांटिफाई करें तो parenthesize the part of the statement where the quantization applies. Okay? So, if I'm not saying that this is correct or wrong, but just giving you the syntax of it. Okay? If I were to, for example, do this, तो फिर this would not be a proposition. Okay? This would not be a proposition because x and y is only applied to this part. It's not applied to this part. Okay? By default, अगर मैं, where is the eraser? By default, if I remove the parenthesis, x, y only applies to the first part. Okay? This is equivalent to जो भी मैंने parenthesis लगाए थे. Okay? To make it apply to the whole statement, you need to do this. Okay? So now this statement is saying that there exists some x, और उसके बाद यहाँ पे it's better to quantify every variable separately. Okay? There exists x and there exists y such that x minus y is greater than 0 or x minus y is less than 0. Okay? But this is not what this statement is saying, isn't it, right? So you want to just put a greater than or equal to here? Okay. I don't think that's correct so far.
So, it can also be y minus x because it is defining difference of two integers, x minus y and y minus x.
Okay. Okay. So the thing is, x and y are variables. Okay? Which means कि x भी कोई वैल्यू पिक कर सकता है, y भी कोई वैल्यू पिक कर सकता है. x अगर मैंने फिक्स कर दिया होता ना कि -2 है, y is -3, then I would have to repeat this for x is equal x minus y और फिर y minus x, because these are two different things, right? But if they are variables, then in this case I would say कि यहाँ पे x is -2 and y is -3, and then I could say in the same instance x could be -3 and y could be -2. Okay? So मुझे y x करने की ज़रूरत तो नहीं है, so I'm fine with that. So let's read what this thing is saying. Okay? What this thing is saying. This thing is saying कि कोई x है, there is some x and there is some y for which this statement is true. Okay? But that's not what we are saying. Our statement is more generic, right? क्या? Okay. Okay. So she's suggesting that we remove everything here. And we write x minus y is less than 0. Is this what you're suggesting? Alright, I think I'm gonna, this is not a very great example to teach you what I'm trying to teach you. The answer for this is there are multiple ways to write it down. But over here, if I write for all x, for all y, their difference is either greater than or equal to 0 or less than or equal to 0 will suffice to quantify what I'm saying here. Okay? So this statement is saying okay, there is a possibility that the difference of two negative integers is positive, and it's saying that there is a possibility that their difference is negative. That's what this statement is saying. Okay? And that's what this would be if I change this with universal quantifier. Okay? But there might be multiple ways. So I am not sure कि slides के ऊपर क्या लिखा हुआ है. So what do I say? Okay, this is wrong. ये slides के ऊपर गलत लिखा हुआ है. Okay? This is not what it is supposed to be. Okay, so think this is the answer. Okay, for all x and for all y, their difference is either positive or their difference is negative or it's 0. Okay, this is not correct. यहाँ पे अगर क्या
प्रोफेसर जब देयर एग्जिस्ट आई है तो हम वो तो नहीं मतलब यही है कि अगर हमने स्मॉलर देन लिया है तो ग्रेटर देन भी एग्जिस्ट करता है.
So this statement is a bit ambiguous. That's the reason we have to do this on. Okay, let me try to figure out a way to write this statement which makes it more clear. Okay, necessarily की जगह के ऊपर अगर मैंने always लिखा होता तो फिर this is the correct answer. Okay, necessarily की जगह पे if the statement was the difference of two negative integers is not always negative, okay, then this is the statement. Okay, okay, are we on the same page? Yes. Okay, do we all agree कि अगर यहाँ पे necessarily की जगह पे always लिखा होता तो फिर this is what we are looking for. Okay, all right, I'll change this. Mehreen, remember इस slide में हम change कर लेंगे इसको. Necessarily को हम कर देंगे always. ठीक है? All right, precedence. So again, the statement I made a moment ago. Universal quantifier applies to the first occurrence of that variable. You see statement के अंदर. Okay, if you have a compound statement उसके अंदर and है और है parenthesis और बार सब कुछ हो रहा है जो पहला compound part है उसका that's where the quantization is going to apply. Okay, so for example if I have a statement which says that for all a p of a and q of a, this quantization does not apply to the q of a part. Okay, it applies to the first part of the compound statement which is just p of a. Okay, so if you want to say for example, so the statement is that this is not equal to जब इसके complete अगर पूरी compound statement को आप quantize करना चाह रहे हैं तो you would have to parenthesize the whole thing. Okay, जैसे यहाँ पे हुआ है. If I want to say that there exists a for which this whole thing is true, I would have to parenthesize the whole thing. Okay, keep that in mind. People, I mean, this is a slide from like I don't know, few years ago, but people make this mistake almost every year. I see people making this mistake. Okay, on their exam. So if you do this, if you write this thing and you mean this thing, you would get a 0. Okay, keep this in mind. This parenthesis is very important. Also be mindful of the domain of the variable when dealing with quantifiers. For example, if I write this statement which says that for all x, x square is greater than x. Okay, without a domain, you cannot tell me whether this is true or false. Okay, because for if my domain is positive integers, this statement is false. Hold on a second, why is this false? Yeah, so it's false, right, for numbers between 0 and 1. Is it true? Hold on a second. For all x, yeah, it's false for x is equal to 1, right? If I change my domain to all positive integers greater than 1, the statement becomes true. Okay, awesome. Cool. So these are two things that you keep in mind when you are quantizing these things. Okay, precedence, parenthesis, or दूसरा domain. These are not the main topic of quantization. इसलिए लोग भूल जाते हैं कि ये हमने करना है. But at times they make your statement what you don't mean to make it. Okay. Any questions? Okay. When you're trying to prove universally quantified statement, you need to prove it for every member of the domain. Okay? That's the definition of universally quantified statement. Okay? So usually proving universally quantified statement is really hard. Okay? Because you need to prove it for every member of the domain. But disproving a universally quantified statement is usually very easy. Okay, all you need to do is you need to find one example, one member of the domain for which the statement is not true, and then you're done. Okay, so keep that in mind. Proving universally quantified statement requires you to prove it for every member of the domain, which sounds like a harder thing. Okay, but disproving it usually is easy. Okay? You just need to find out one example. उसको हम counter example कहते हैं. One example or one member of the domain for which the statement is not true, and then you're done. You have disproved it. Okay, it's the opposite for existentially quantified statement. Proving existentially quantified statement is extremely easy. Okay, because you have to show the statement is true for what? For anyone, for just one member of the domain. Okay, if it's true for one member of the domain, you have the existential statement. Okay, but if you want to disprove it, oh boy, then you have to disprove it for every member of the domain. Okay, so proving universally quantified statement and disproving existentially quantified statement are the hard tasks. Okay. Again, people forget this. Okay, keep this in mind. The question: if a universally quantified statement is true, does that mean that existentially quantified statement is the same statement? Okay, I'm not changing the statement. What I'm changing is just the quantifier. Okay, universal quantifier मैंने लगाया and the statement is true. If I change my quantifier into an existential quantifier statement, does it remain true? Yes, we all agree. Okay, if the statement is true for every member of the domain, it's definitely true for at least one member of the domain. Okay. How about if it's not universal? If it's false with the universal quantifier, is it false for existential quantifier as well? Okay, why not? Someone with raised hands. Yeah.
Because at least one might be true even if not all of them.
Yeah. If universally quantified statement is false, which means that it's not true for everyone. Okay. Which means that it might be true for some of them. Okay. So a wrong or a false or a false universally quantified statement does not mean a false existentially quantified statement where the statement is same. Okay. You had a question? Speak louder, I can't hear you.
Can I turn my phone off? I forgot to turn
Or you want to? Yeah, go ahead. Go ahead. Okay, so that's yeah.
I do not understand the last thing about
Okay.
universal quantifier being false.
Okay, sure, good. So what is a universally quantified statement? The universally quantified statement says that whatever the statement is, okay, let's say कि जो मेरी statement है उसको मैं p of x करता हूँ, okay? So I have some statement p of x, okay? This is a predicate, okay? When I say an x is member of some domain, okay? Some d. For all x p of x, what I actually mean is, what do I mean? What I mean is p of x1 and p of x2 and p of x3 and so on, okay? And p of x1, assuming there are finite members of this domain, okay? This is what a universally quantified statement is, okay? What I'm saying is that when I say that this is not true, okay? What I'm actually saying is that this is not true for at least one of them, okay? हो सकता है यहाँ पे कुछ चीज़ें true हों और हो सकता है कुछ चीज़ें not true हों, okay? That's when I make this statement false, okay? So what that means is that if I have a negation of for all x p of x, okay? This is not equal to or equivalent to negation of there exist x p of x. Okay? So the theory is it's possible that some of these statements are true and some of these statements are false. Okay, which means that it's possible that there exists some x for which the statement is true. Okay, negation of universally quantified statement is not the negation of existentially quantified statement. If the statement is same.
If the statement is false universally, then doesn't it mean that it is false for every value?
No, it does not mean that. Okay, it's just the negation of this thing. Negation of this thing is इनमें से कोई एक भी false हो गया तो ये false हो जाएगा. Okay, if one of them is false, this would become false, right? It does not need that every one of them is false to make it false. ठीक है?
How do we know that one of them is false or like either one of them is false or all are false?
Oh, you have to check it. This does not, when I say negation of for all x p of x, it does not tell you how many of them are false. Okay? All it's saying is there is at least one for which the statement is false. Okay? ठीक है? क्या? You don't know how many हैं. Okay? हो सकता है कि वो सबके लिए false हो सकता है कि वो सिर्फ एक के लिए false हो. Okay? Good. Where did I put my... do I want to ask another question right here? Okay, how about this? If the statement is true for existential quantifier, is it true for universal quantifier? Not necessarily, right? It's not necessarily true. If the statement is false for existential quantifier, is it also false for the...
Yes.
Yes, no? Think about it, give it a second. So all I'm saying is that there is an existentially quantified statement and it's false. Okay? It's not true. Does that imply negation of for all x p of x? Okay? It does, right? So this thing is saying कि कोई एक भी x ऐसा नहीं है जिसके लिए p of x true होगा. Okay? And this thing is saying p of x is not true for all of them. Okay? This is much bigger set than this one. Okay? This thing is saying that there is not a single x for which p of x is true. Okay? To make this true, you only need one x for which p of x is not true. And this thing is giving you everything. For all of them, this is not true. Okay? Good. Free and bound variables. So when you have predicates, you will have some of the variables which are free and which some of them are bound. Okay? यहाँ पे to make a predicate into a proposition, you need to bind every variable in the predicate. Okay? यहाँ पे हमने सारे variables को bound किया है. जो variables quantify नहीं हुए वे those variables are, what are they? They're free. Okay? They're freed up. Okay, let's just read through the definition. A variable x is free variable because variable is free to take any value. Variable x in the statement for all x p of x or there exists x p of x is bound. Okay? इसको bind कर दिया हमने. A statement with no free variables is a proposition. Okay? You need to bind every variable to make a predicate, a proposition. Part of logical expression to which a quantifier applies is called the scope of the quantifier. Okay? And a moment ago I told you that if you don't use the parenthesis, the scope of this variable is the first proposition, first complete proposition. Okay? जहाँ पे वो appear हो रहा है. Okay, let's move on. For all x, p of x and q of x is not a proposition. Why? Does it sense? Yeah. So now scope is defined. Scope is defined, but yeah. So the scope of x is just the first part of this proposition. Okay. The x in p of x is bound. The x in q of x is not bound. Okay. The scope of x is just p of x. The second part is a proposition. Both of these instances of the variables are bound. There's no free variable. Okay, is this clear for everyone? Okay, I think I had a more elaborate example. Yeah, okay, now we're going to do De Morgan's law on quantifiers. Okay, this is going to be probably the last thing that we do today. So here's the universal quantified statement. I think this would clear every confusion that you have for quantifiers and their negations. Okay, cool. So our example is that every student in this class has taken a calculus. Okay, and this is how we write it. For P of x means x has taken calculus. Okay, when I say for all x P of x, I mean that everyone in this class has taken calculus. Okay, stop me at the moment I stop making sense. Okay, किसी point पे आपको लगे कि ये वाला point मुझे नहीं समझ आ रहा, stop me there. Okay. Alright, so this is what it means, that it's true for this guy, it's true for this guy, it's true for this guy. Okay, it's true for every member of the class. Okay, that's the definition of universally quantified statement. Moving on. What's the negation of the above statement? What's the negation of this thing?
No one has
That's not what the negation of this thing is. So let me kind of go back to our first class, जिसमें हमने negation define किए थे. Okay, negation of a proposition is another proposition जहाँ पे it's false when the original statement was true, and it's true when the original statement was false. Okay, it's direct opposite of the truth table of the statement. Okay, that's what negation is. So now I'm asking, what's the negation of for all x P of x?
For all physical real exists.
Okay, you're kind of 5 steps ahead of where I want to be, but hold on a second.
at least one student hasn't taken calculus.
Yeah, there is at least one student for let's see, how do I do it on slides? It's not true. Okay, if I write this thing, it's not true, I get the negation of the statement. Okay, okay. So let's write it down in a very simple way. It's not true that every student in this class has taken the calculus. What does it mean? This means that there is at least one student that has not taken the calculus. So far with me?
Yes.
Everyone? Okay. So how do I write this thing now? There is at least one student that has not taken the calculus. I write it using, I mean, this is simple, right? There is at least one student. At least one का मतलब ये है कि I can use existential quantifier now. Okay, and what's this? Not taken calculus is the just negation of P of x. Okay, P of x says x has taken calculus. Not P of x says that x is not taken the calculus. Okay, so this is simple now. I can write it down as this happens, or this happens, or this happens. Oh, okay. So I get there exists x negation of P of x. Okay, are we good? Please stop me if I'm not making sense. Okay, let's move on. Negation of quantifiers. So negation of for all of x is equal to this. This is the definition of for all x. This thing is equal to something else. Let me. This thing is equal to by De Morgan's law, जो हमने देखा था अभी. This is equal to this. Okay. Remember De Morgan's law apply करते हैं. You negate every statement जो अंदर है, and you flip the operator जो आप use कर रहे थे. Okay. So I negated P of x1, I negated P of x2, negated P of x3, and then I flipped all the operators. Okay. यहाँ पे and operator था, तो I would have or operator here. Okay. And this is equal to there exists x, not P of x. Okay. And this is now equal. Okay, so I've just kind of proved that negation of for all x P of x is equal to there exists negation of P of x. Awesome, good. This is the kind of arguments I expect when I give you propositions to prove or disprove. Okay. So let's see how we deal with the negation of an existential quantifier. Okay, negation of existential quantifier means that it's not true whatever existential quantifier says, right? Let's do that. So it's negation of p of x1 or p of x2 or p of x3 and so on. Okay, everything within the parenthesis. Okay, अब यहाँ पे आप De Morgan's apply करेंगे तो what do you get? Yeah. Again, you are 2 steps ahead. But what I'm saying is that you would negate everything within the parenthesis, and then you flip the operator. Awesome. This is what you get. Okay. And अब यहाँ पे you have a bunch of statements और उन सब के बीच में and लगा हुआ है, which means that this is equal to for all. Okay. So it's for all x negation of p of x, whatever you said a moment ago. Okay. All right. Are they good? Okay. Nested quantifiers. We have about 5 minutes. Okay. Let's do nested quantifiers. ये kind of मैंने अभी कर लिए थे आपके साथ जब हम यहाँ पे कुछ कर रहे थे. We did something about x and y, right? है ना? So we had multiple quantifiers already. That's called nested quantifiers. Okay. If a predicate has more than one variable, each variable must be bound by a separate quantifier. A logical expression with more than one quantifier that binds different variables is the nested quantifier. For example, you can have there exist x for all y p of xy. Okay. Okay, I wanted to say something on this slide. Am I forgetting? Let's go back. What could be said on the slide? No talking, guys. So the question I want to ask is, if I flip the order of the quantifiers, does it make any difference?
Are the domains same?
Domains are same. Okay, so what I'm saying is, let's assume that x and y both are integers. Okay, I say there exists x for all y p of xy, and then I say for all y there exists x p of xy. There's a difference? What's the difference? Think about it. I'm going to give you 15 seconds. Okay? Actually, I can't see this number of seconds on this match, so jitne lene hain le lo. Sorry, what?
We are changing the universal quantifiers and then
No. So I'm gonna keep the variables there. Okay. So let me be clear what I actually mean. Okay. So I kind of succeeded in confusing you finally. So what I mean is that this statement equal to for all y there exist x p of xy. Okay. I'm gonna keep the variable with the same quantifier जो मैंने पहले use किया था. Okay. Okay. So that's what I'm saying. That is this statement same as this statement?
Yes, sir. The domains are same.
Yeah. I'm looking for people who say that they are not same, and I want them to prove that they are not.
Sir, are you saying that that statement is true?
Okay. So what I'm saying is this thing true? Oh boy. Oh boy. That's good. So there exists x for all y p of x y. Okay, so this is what I'm asking. I'm asking, is this proposition true or false? Yeah. People who say false. You say false, okay. Another one. Okay, I converted about 3 of you. Why is this false?
In the first statement, you place y with x.
Okay.
P of x and y to p of y of x.
Okay.
Yeah.
Okay. फिर then it would be true. But why is this false? Why is this thing false? That's what I'm asking. Okay? I'm understanding कि तुम इसको true करने की कोशिश कर रहे हो. That's fine. But why is this statement false? If you say that this is false, क्या?
Can I explain an example?
Yeah, sure.
Like if we have example that for all lectures, for all universities, there exist lecture theaters
Okay.
or lectures.
Okay.
Then we can't say for all lectures there exist universities.
Okay, here's the thing. To give me an example, you need to find two different domains, or same domain but two different variables. Okay, so come up with two different variables here. So I see one variable which is universities, and the other one is lectures. Okay, so what you're saying is that for all universities there exist lectures, and what does P of X, Y says? The same thing. Okay, come up with a more kind of clear example. You were on the boundary or something? I have switched the quantifiers, yes? But I kept the quantifier with the same variable. So ये variable यहाँ पे आता था. So I kept it there. Almost everyone believes that this is true. This is true? You think it's not true? Then you have to convince me that this is not true. You cannot go around making a claim without a proof. We're in the discrete class. This is the statement. I am asking about the truth value of this statement. The statement is false. The statement is not true. Now I want you to figure it out why this is not true. Do you want me to give you the example? Or you want at least 60 minutes to figure out why these are not? 60 seconds?
Sir,
Yeah.
what if you take an example that for all whole numbers there is this natural number?
That's not a statement.
We can disprove it nothing like
Come up with a more clear example, okay? Try making examples. You guys are stuck somewhere. The examples I gave you are the ones that... Sorry, what? Sorry, what?
For all soldiers, there exists a gun.
For all soldiers, there exists a gun. Okay, sorry, what? Again? I'm stuck at the soldiers.
For
Okay.
all soldiers,
Yeah?
there exists a gun.
Which the soldier holds, okay?
For all guns, there exists a soldier. So false statement.
But here's the thing. अभी आपने क्या किया? अभी आपने variables भी change कर दिए हैं. This is not the statement जो आप कह रहे हैं. Okay? हमने यहाँ पे variable भी change कर दिए हैं. Quantifier stays the same. With the quantifier अगर soldiers के साथ था तो soldiers के साथ ही रहेगा universal quantifier. Okay, let's. Okay, let me give you an example. X, Y, domain of both X and Y is the students in this class, okay? For everyone in this class, P of X says that X is, X and Y are buddies, okay? For everyone in this class, there's someone who is X's buddy, okay? Or Y's buddy. Okay, this is what this part is saying. And for everyone in this class, there is at least one person who he or she is buddy with. Okay? Okay. Let's come back to this part, what this is saying. This part is saying there is at least one person in this class who is buddy with everyone. Okay, so these two statements are completely different. This part is saying that everyone has a buddy. Okay, ठीक है? This over here I'm saying that for everyone in this class, there is someone who Y is buddy with. Everyone has at least one buddy. This part is saying there is one pathetic person, or I don't know, celebrity, or whatever you want to call that person, and he or she is buddy with everyone in the class. Okay? So these are totally different statements. Okay? One might be true, other might be false. Right? So it matters. The order of quantifiers matters. Okay? Are we good? Is this clear to everyone, or is someone who thinks that this might still be true? Okay? This is not true. Generally, this is not true. Okay? Awesome. Cool. That's about it. Thank you. I'll see you next Thursday.